Good afternoon, everyone, and welcome to Code of Conduct, the backend engineering podcast, which is by engineers and for engineers. This afternoon, I'm joined by Hunter Brooks, who is currently a senior engineer at Amazon. So hi, Hunter. Thanks for joining us.
Thanks for having me.
So Hunter, I reached out to you initially because I looked all through your LinkedIn profile. I thought your background was amazing. But for the people who don't know you and haven't had the privilege of seeing your profile, can you just give us a little bit of insight into your background?
Yeah, I took a pretty atypical path to software engineering. My undergraduate degrees are in physics and astronomy from Penn State. I went into those fields because, number one, I had an interest in explaining the natural phenomena of the universe. After all, astronomy is the oldest science that mankind knows. And number two, physics is a general problem-solving degree. If you can decompose a complex system into its relevant, important parts and do thought experiments of how changing those parts would impact the system. I mean, that's what modern day software engineering is. So I'm now a software engineer at Amazon. I work in Amazon advertising, where I apply a machine learning model to basically serve more personalized ads on the internet. But it wasn't always clear that I wanted to go into software engineering and computer science. Originally, I wanted to teach undergraduate physics for the same reasons that, well, I think physics is relevant and important, and everybody should be able to learn it, even if they might not enjoy it. And in order to prepare for grad school, I joined a research group. And this research group was people who had PhDs, basically longer than I've been alive, postdoc fellows, a bunch of very smart academics. I was the undergraduate researcher. My main responsibility was basically taking the models, the physical phenomena, the hypotheses that they had, and testing them against the data that we observed. So my field of research was in cosmology. We commissioned time on about 20 different telescopes, including the space telescope, Hubble Space Telescope, and basically took observations of galaxies that are about 2 billion years away, 2 billion years back in time, and compared it to what we think we would be. And that's glossing over a lot of complications because it's basically an exercise in building an ETL pipeline and making a analytics tool to compare hypothetical or anticipated outcomes to what the actual spectral energy distribution of those galaxies is. So I had to teach myself Python to run ETL on basically a small program that I built to normalize the data from all the different telescopes. And then the second part of it was to choose hyperparameters based on what the PhDs and people I worked with thought were likely to describe these galaxies that we were looking at, and put them in a tool that takes anticipated settings and outputs what the light from that galaxy actually would look like. And then we match the two, tweaking the hyperparameters that go into the model over and over again until we got a good match. Once we got a good match, we could basically justify that or be confident that it's likely that a galaxy looks a certain way or has a certain number of red dwarf stars or G2 stars or something like that. But I never went into it thinking that software engineering was going to be the thing I focused on. I was never really a coder or enjoyed it, frankly. I kind of taught myself software engineering through all the fabulous tools online to learn Python because I wanted to learn about the science. But as I did that over maybe the course of 3 years, I started to lose interest in the natural science of it and become more interested and get more satisfaction about learning a new method in Python or a new tool or a new library or things like that. And eventually I decided to go into computer science so that I could formally improve those skills and in a professional way build software systems.
Perfect. I mean, first of all, I think there's kids' hearts breaking all over the world to know that being an astronomer doesn't involve just looking through a telescope and like just the coolest sounding job in the world. But that's really interesting. And I think again, you're at Amazon at the moment, you work to Capital One. Like, for a lot of engineers who are starting out, or who are in engineering currently, probably have the misconception, right, that if I want to work at a FANG, or if I want to work at a really reputable tech company, I have to have gone to an amazing college, and I have to have studied computer science degree, and I have to live and breathe coding day in and day out, or I'm never going to get there. So how did you, I guess, empower yourself to make these applications, right? And just think, you know what, I'm going to go for it. And it's obviously worked out for you.
It was a bunch of trial and error. So like I said in the beginning, I didn't know any difference. I didn't know anything about Python. The only data structures that I knew were string, number, and list that could contain strings and numbers. So it's all just an exercise in grit, I think. There's a lot of time spent being frustrated at your laptop when you don't have a classical background in computer science. Having said that, there's more so today now than when I was in college, a bunch of great resources out there to be able to learn to code, or take a boot camp somewhere, and things like that. So if you're motivated about it, you can definitely make it happen. Yeah.
Are there any drawbacks other than obviously that frustration, sometimes maybe your brain not naturally knowing how to solve these problems? Are there any other drawbacks of being self-taught?
Yeah, so you're going to flunk a lot of interviews in the beginning, especially the data structures and algorithm interviews, again, because you don't have that classical training that all of your colleagues have. And then there's kind of the intangible effect of, do you really belong in that group? And that gets into imposter syndrome, which is something that all developers face, regardless of their gender or background or wherever they're coming from. And that was particularly relevant for me because when I joined Capital One, I joined in a campus hire class of like maybe 150 people. And of them, 10% were brought in at the senior associate level, and the rest of the people were at the associate level. I was one of the 10% to be brought in at the senior associate level because I had a background in the hard skills, but also the data science associated with what they're trying to do at Capital One. So I felt out of place compared to my colleagues that knew every keyword in Java and how to do leak code mediums in their sleep. I totally felt out of place. I was the same person that didn't know what a set was in the interview question, but I was here working at a level above these other people technically. So yeah, I think if you think that, yeah.
So there's a couple of points there that are really interesting for me. Like, obviously imposter syndrome, which is something, throughout the series we've spoken about. It seems like the impossible subject to avoid because it is so prevalent in the industry. And like you say, it doesn't discriminate age, gender, race. Like, everybody who is an engineer probably lives and breathes it. But I mean, for me, one thing that's really interesting is you were selected as this 10% of seniors. And so you'd kind of proven your worth at this point, although there may have been questions in your interview that you didn't necessarily know. And you still had that underlying feeling of, I don't belong here, I'm no better than anyone else around me. Like, how did you combat that to the point of not just being able to survive, but also thrive and forge a successful career for yourself in like the second year?
Yeah, I really went in not being confident in myself. Luckily, all the projects I worked on were cloud-based, and all of my colleagues were new to cloud computing. So to some extent, it was like in the technical realm, we were all learning new skills and new paradigms, especially in AWS. But yeah, it affected everybody. I could tell people on my team were nervous about working with somebody after having been there for 4 years, that I was just a campus hire at their level. But what really helped me is to understand from senior engineers the decisions that they made. So really pressure them to explain their thinking and to articulate if they did make a trivial choice. I think there's been times where I've overanalyzed a situation or an architecture, especially in a backend system, that was chosen for some silly reason. And at the time, it's fine. but there wasn't a whole lot to learn from it. For example, if somebody is familiar with Postgres over MySQL makes sense for their database. They're trying to get their application off the ground quickly. So if you have the perseverance to kind of have somewhat difficult and somewhat confrontational discussions in obviously a very polite way, then you can learn a lot, and you can develop that confidence for yourself in year 2 and 3.
Interesting. Yeah, that's a learn in itself, right? Is you have to ask questions and you have to learn, but you can get to the point of almost making yourself a busy fool. It's like, I'm trying to learn so much that I'm actually not learning anything, because I'm taking it all in and I'm analyzing all of that, which is interesting. But you're obviously someone, to me at least, who comes across as incredibly passionate. Right from an early age, whether you realize it or not, it was kind of destined for a career in software engineering, because you just love problem solving. Like, that's like what you wanted to do. So I want to pick your brains a little bit. Like, you're clearly very talented as a backend engineer around new trends around technology. Is there anything particular, and we've had a crazy year, so I'm sure there's all sorts of things that are on your mind, but from a technology perspective, is there anything in particular that you're like most looking forward to working with or diving deeper into?
Yeah, I think one reason I have been able to cover a lot of ground in my relatively short 5-year career is that I've been able to iterate quickly and try new technologies very rapidly. And that, I think, comes down to the developer experience. And that's something that I've been focusing on a lot lately. If you have a developer experience set up, and that normally involves third-party APIs that do the things that you don't really care about. For example, Stripe API to do your billing, or Plaid API to pull bank accounts, maybe SendGrid to send emails, things like that. It allows you to iterate quicker on the thing that you're trying to build, and whatever that product might be. And so this collection of prominent, powerful third-party APIs that are powering startups and cloud computing, those two together make it so that you can build anything quickly. Today, we see people being able to stand up a total Kubernetes cluster on their laptop in 5 minutes, or stand up a Node.js React service in a couple seconds. And then it's not much more work to deploy to the cloud and to go from your first customer to your 1 millionth relatively easily. I don't have an appreciation for it because I wasn't really around before cloud computing, but I've heard that was a difficult problem in the past. Today, it allows you as a developer to try new things and to fail fast and learn.
Mm. And you mentioned Kubernetes just now, and it's something, in my line of work, I hear all of the time and more frequently, as people are getting really excited about containerization. So from your perspective, is there any real benefit to working in a containerized environment? And if so, like, what does that look like for you?
Yeah, so I have my own personal stack that I use. I think containerization is really important because it removes the issue of for me. Like, oh, well, the test passed for me, or the integration test worked for me, or the build works for me. It allows teams of developers that come from different text editors, different stacks, probably different architectures on their own laptop, like Linux or Mac versus Windows or something like that, to be able to focus on the problem itself. And then once you have been able to build the software, it allows you to ship it a lot easier. It's very simple to build an application that can auto-scale on the containerization, on the container level, than to, for example, provision a new machine and then wire it up somewhere and route traffic to it.
With cloud computing, and everyone's kind of got their different opinions on AWS and GCP and Azure, and some people who are still on-prem, like, when you talk about building things for scale, what impact would cloud computing actually have on that for you, and a different, I guess, preference in terms of different cloud environments?
Well, it allows you to grow your app real quickly. And so the combination of these APIs that solve different problems that you have, for example, sending emails to your customers or scheduling things like that, with cloud computing, it allows you to just focus on the problem that you're trying to solve for your application itself, as opposed to getting stuck up, say, in the nitty-gritty of scheduling a cron job. Instead of having a box somewhere that runs cron to fill a queue with user IDs to do something on them, now you can just use something as simple as AWS Lambda. And it's almost a no-code solution because a lot of these things are configurable from the web console itself. Now, when you start to get into your architecture as code, your infrastructure as code, then you get both the power of cloud computing and the source control control and benefits of peer review and things like that with having your infrastructure checked into GitHub.
Interesting. And your role at the moment at Amazon, it focuses a huge amount on machine learning, if I'm not mistaken. And it's something that, you know, before I got into tech recruitment, I'd always thought machine learning was like, what's that robot movie with Will Smith?
I Robot.
Yeah, that's kind of like, that's where my brain always went to. And now it's kind of the new cool thing, which everyone's talking about. I feel like not a lot of people still understand what it really means, but it seems as though ML is at the core of a lot of what you do. So I guess in its plainest and simplest terms, like, what does that look like, and how has your role changed since you've been able to prioritize machine learning?
It's gotten a lot more fun, actually, because I think the class of problems that machine learning techniques can solve is very vast. It's great at personalization. So Amazon, in Amazon advertising, that's what we use it for. We use it to serve more personal ads to people all across the internet. And it's also brought with it a whole new set of problems. For example, I didn't used to do a lot of data engineering. I spent my time building mostly APIs where I cared about things like, well, the containerization of my product and the integration with a third-party API and, you know, security with JSON web tokens and things like that. But as a data engineer on an ML product, a lot of my concerns are around moving data at a regular enough cadence and at a large enough scale. So it's kind of shifted from a runtime inference, which is being taken care now of by the algorithms, to like more of a batch processing job. And that's just for me. I can only speak for myself in that, but it forced me to get familiar with a whole new set of tools. So Spark, you know, distributed databases, those type of things are now what I use more than, you know, React or Node.
Mm-hmm. Now, first of all, thanks so much, because you're the reason why I've spent hundreds and hundreds of dollars on my vacation wardrobe, because I did do it all through Amazon, and everything that came up, I was like, damn, this is exactly what I was looking for. So thank you for that. But second of all, again, we talk about machine learning, and, you know, we touched on it before, but being able to do it at scale, and what you're actually doing, like you say, it makes it more fun. You're impacting, I mean, I don't even want to hazard a guess as to how many users, but what about for engineers who, you know, like you, they are passionate about new trends, new different areas of technology, but maybe their company isn't ready to move into machine learning yet, or maybe they just don't have the know-how in-house to be able to do it. Is there anything that engineers who are interested in that space but can't work with it every day, is there anything that you would advise that they start looking into, or they start practicing to perhaps get them to where they want to be?
Yeah, there's a bunch of great tutorials on the internet for learning to use ML and its use cases. So one of the ones that comes to mind for me is a numbers classification problem, where there's a data set out there of handwritten numbers, and basically it's easy on a simple laptop to train an ML model that can classify those handwritten numbers as the digits that they actually are. And so that's a good exercise that takes you through the important part of building a machine learning pipeline. You have to clean your data, you have to standardize it so it can go into your model. You have to architect the model itself, because obviously not all ML algos are made the same. And then you have to be able to interpret the results, because it's not a Boolean. The scissor is not a number 8. A model is always an estimate. And then once you've done that, you basically have your homegrown number guesser. You could build something like a pipeline. Imagine you got a bunch of new numbers in every single day, and you had to run the same process. So you're interested in things like retraining and being able to pick the best model of a couple competing models to use for the next day in production. And that's when it gets from more of like a hobby project to something your company might do later on down the line. But I think machine learning has never been more accessible than it is now. There's a bunch of YouTube videos and online open source guides for it. So if you're interested in it, spend some time. One thing I will say though, don't get sucked into the idea that it will solve all the problems. Machine learning may or may not take over the world, and AI might replace us all. But right now it's not even close. And so it's probably overkill in a lot of the examples that I see out there. especially when there's great statistical techniques like linear regression that do just as good, if not better of a job than, a enormously deep machine learning model.
So I don't need to worry, robots aren't gonna, replace us all in my lifetime by the sounds of things. But it is on everyone's lips, right? And so are a lot of different things. It's technology, it's ever moving, it's constantly changing. So with that in mind, like, you seem to have been able to navigate your career quite successfully in terms of learning new things, but learning them well and being able to actually use them in the workplace. But what advice would you give to somebody who's like really eager to try everything? They're like, oh my gosh, this is all so exciting, like a kid in a candy store, but it actually prevents them from learning to the point where perhaps their knowledge is like an inch deep, mile wide.
Yeah, don't fall into that trap, is what I would say. I think there's a lot of shiny new things in the tech world, especially on the back end side, related to machine learning, blockchain, all those topics. But it's not great to know nothing about everything. I would rather be able to work with a colleague that took a problem and solved it using technology, rather than getting too wrapped up in the many ways using technology there are to solve that problem. There's always going to be different ways to solve the problems in the software engineering world. After all, we are engineers. We're creating something from nothing. We're building code from concept. So there's, an element of art to it. But at the end of the day, it is a means to an end. We do use technology to be able to solve business problems. So instead of just jumping on the next new thing, maybe you jump, if you're a new engineer, onto the next new thing once you've been able to create a product or solve a problem with it. And that basically just means delivering what someone else wants. So if you're a backend engineer on the team and you think that GraphQL is awesome and you want to build a graph database and expose it to the front end team at your company, I would say that that is a good example of using a new technology, as opposed to just learning, a GraphQL API and building a schema and then never touching it again. In one case, you actually help somebody and you delivered a result for a customer. In the other case, you just read the Wikipedia page.
That is such good advice. And I think it's applicable no matter where you're at in your career. I often see the resume sentence of doom, which is highly experienced with Python, Golang, Ruby on Rails, Scala, Elixir, Python, React, and you're like, whoa, you've got like 4 years experience. Like, is it possible that you really are an expert in all of these areas? And I think you hit the nail on the head. Like, you would much rather, I think it was actually a director of data science I once worked with that said, I would so much rather work with somebody who knows what they don't know, and what they do know, they know really well. And I was like, that's really poignant, and it's so, so relevant. You kind of sound like you've fallen into that trap before. Have you ever kind of been like, I need to learn everything? And how did you, I guess, check yourself to be like, okay, this actually is counterintuitive?
Yeah, I definitely did. Earlier on in my career, I wanted to build a company. So I needed to know how to build a mobile app. I need to know how to build a backend. I need to know how to build some sort of analytics engine to capture the data and act on it. And frankly, that's just not possible. You can be a generalist, and that's relevant today, but you can't stay up to date on all the trends in emerging technologies and be proficient at them in today's technology world. I mean, there's just too many things to know and to learn. So yeah, I've definitely fallen into that trap. The way I normally get out of it is, again, I ship one thing at a time, and I totally shift focus when I do between products. So lately, I've been spending some time learning React, and in particularly how these no-code and low-code solutions build front ends, the code that's generated from them. But before that, I spent a lot of time with AWS, Lambda, and Flask, and building a very simple containerized app. That's all in the back end to be able to go from API, or from nothing to API in about 5 minutes by just defining the schema. So those two don't have much overlap between the two, but both of them on their own, I think, would be helpful.
Okay, so it's kind of, learn it, box it, and kind of move on, rather than I'm doing everything all at once. Yeah.
Right.
That makes sense. I mean, you seem to have a very thoughtful, methodical process in terms of just how you approach a lot of things. And, you can correct me if I'm wrong, but I'm assuming that you've done your fair share of interviews. We talk about imposter syndrome, we talk about not feeling like you belong, but success, and I'm pretty sure there's been some epic failures in there as well, and you've obviously bounced back from it. So, for our listeners out there that maybe just bombed an interview or don't want to apply for that job because they're never going to get it or whatever it may be, is there anything that you've learned in your career when it comes to interviewing or even hiring, really?
Yeah, I would say don't get your head down. There is a large, non-trivial percentage of luck that goes into any interview outcome. It could be how the hiring manager was feeling, or something as simple as the question was asked might have been one that you've seen or similar to another one that you've seen before. So I think there are guides out there that will tell you you have to do 10 hours of leak code practice a day to land a phone interview at a FANG company. And my answer to that is don't buy into it. There's plenty of fascinating companies out there that are solving challenging problems that are smaller and you might have not heard of them before. So don't just evaluate opportunities based on the prestige of the company. In fact, small companies to some extent, like they hold a special place in my heart because you get to move a whole lot quicker. And normally the developer experience, like I mentioned earlier, which is so critical to growth as a developer, is a lot better, and you can ship code quicker and get feedback from senior engineers, even if there's only 2 or 3 senior engineers at your company. So yeah, the interview process is luck. It does require a lot of hard work to improve your odds, but you basically need to be able to represent yourself for what you care about and how you can help a team honestly, and hope that resonates with people.
Interesting. So it's more about staying true to yourself and the skills that you have and the value that you can bring, as opposed to shape-shifting and morphing your values and your beliefs and your skills constantly to kind of fit the narrative of maybe, a company that you've held as a target company that you want to work for, or a dream tech site or something like that.
Yeah, absolutely. Especially when you factor in what type of technologies you want to work with. I mean, if you hate a language, you shouldn't be applying it just because you want that job or that company has a certain prestige.
Yeah, very interesting. There's loads of people that I've spoken to that like, I don't like working with X. It's like, why have you been working with it for 4 years? But there is a lot that can sometimes come with company titles. So I completely get that. And you touch on something really interesting, which is something I'm ashamed to admit, but I've never really thought of myself, is that there is a element of luck to it, because you don't know how the hiring manager's feeling. And in recruitment, and this is back in the day when I was in Manchester recruiting for credit controllers and accounts payable clerks, a very different world to what I'm in now. But we used to have this rule, and my ex-manager will kill me for saying this, but we never schedule interviews for a Monday morning because the candidates likely won't show up. And we never schedule interviews for a Friday afternoon because the clients probably don't want to be there, and so it's always going to be a no. But I'd never kind of carried that logic through, as these managers have feelings and they're tired and there's things that aren't going right in their day. But how do you combat that? Like, how do you remember that isn't you, and you don't let that impact your imposter syndrome, your feeling of self-worth or belonging? How do you take the no's and turn them into something constructive and just say, what, I'm just going to keep going?
Well, you should always be asking for feedback. And this doesn't just apply to interviews. When you're working with colleagues or showing somebody a resume or something like that, get their thoughts, because they've probably have a perspective that, is different than what you think it is. But for dealing with that sort of failure of bombing an interview or not being able to connect with a hiring manager for a position you really wanted, you should take it on the chin and think that it's not, maybe it would have worked out anyway if this was the first interaction, or maybe you thought it was better in your head, and then go build the skills so that for the next company that does something similar, you can, impress those people in the way that you want and get the reactions desirable. I also think a lot of it is your own confidence. If you work on things that you care about, you're going to be more excited to speak about them. You're going to feel more confident in those system design interviews where they ask you to whiteboard a project that you've built before. And those are probably intangibles that you don't think much about, but go a long way, especially when interviews were done in person, to building a rapport with somebody.
that feels like a lifetime ago. I can't even remember the last time I've shook someone's hand. It's like when I watch TV now and they hug, I'm like, stop. feels odd. But so just lastly, Hunter, I'm sorry, I'm giving you a grilling here, but I want to pick your brains on the flip side of that, because you've been a nervous engineer that's interviewed, and you've also been a successful engineer that's interviewed. But you've also been on the flip side where you've been the interviewer for said nervous engineer and confident engineer. And when you're in the hot seat and somebody's kind of, thinking of you and talking to their partner when they go home about what you were like, what are you looking for? What's going to make you remember someone? Or it could be the difference between, yes, this person has potential, to, unfortunately, I just can't see how it's going to work.
I think one of the most important things that's often overlooked when considering how a software engineer is going to fit into a team is their communication style and competency. Especially if it's a small team, they're being trusted with owning different parts of your stack or your flow or whatever it may be. And they really need to be able to communicate their problems, their intended approach, their design. It could be something like architecture at the code level, or maybe choosing which resource you should use for your cloud platform. And if they can't communicate that, you can't have other people auditing it. Or if it's a not so enjoyable experience to get that information, those people who are giving advice and eventually the team itself, they're going to have a less than desirable design, because people might have lost interest in contributing to that, or not as interested as if it read as easily as a book or something like that. I think that's something that's not taught as undergrads, and that itself was probably something that when I was coming into the software engineering world, I had a little bit of imposter syndrome. I wish I had known. Nobody's very good at writing technical documents. Nobody's very good at outlining their API spec or depicting their relational database schema and then defending it against inquiry from senior engineers or other people. I think that's pretty important. So that's something that I look for. I definitely don't look for how fast can you solve this problem? What runtime is it going to be? Like, tell me all these keywords. In fact, I think because our interview system in the industry is so designed to root out false positives, I think the better thing to do is to, as the interview question provider, provide a very simple question and then build on it over and over and over again, and do that for your 45 minutes or 1 hour time period, so that the person, you kind of shake those nerves and you can really see someone's ability to contribute, and they also get an idea of what it would be like to work with you. And so all the interview questions that I ask, a sophomore in computer science in college be able to answer the first round, and then maybe a senior the second round, and maybe somebody who's a junior engineer at the third iteration of the question. And eventually you can build a very simple programming question, which might have an algorithm or a data structure at its core, something like that, into a system design question. And that's probably what it would be like if that person were to join your team as a colleague. You would say, here's a business problem that we have. Can you architect the solution, and what is the key code going to look like?
That's pretty, like, it's taken me back a little bit, right? Because I think there is something fundamentally wrong with the industry where software engineers, and it's one of the main reasons I decided to create this podcast, is so much is taken from engineers, and certainly throughout the interviewing process, where they do 10 hours of prep, like you said, and they can go through these really intense, really vigorous interviews, and they can receive no feedback. Sorry, you weren't the right fit, or whatever it may be. And these interviews aren't always designed to see people at their best. And I'm not an engineer, so all I can do is listen to what everybody tells me and kind of take that all in. And one of the biggest things I get told all the time is, but that isn't how I would solve a problem. In real life, I would pull it up on Google and I would talk to my colleagues, and then I would figure it out. But then you're all of a sudden, again, like you say, pre-COVID times, but you're sat there with 4 people, white to their eyeballs, staring at you in front of a whiteboard thinking, I don't know. So last question, if you do find yourself in that situation where perhaps they haven't got the luxury of being interviewed by somebody like you, that maybe they are just doing the more traditional interview, maybe it's their first time interviewing and they don't really know, and the person interviewing the candidate they're stuck. They don't know how to answer the question. They don't know what to do. Is there a way to bow out of that gracefully and leave with your head held high and ask for help, really?
Yeah, I think number one, don't beat yourself up. These questions are designed to push people to the limits of what they can do. And we only have 45 minutes to do that. So they get hard quick. And it's important to remember that, it, to some extent, it is a little bit of luck and it is a difficult experience and not everybody does it perfectly. So if you remember that and that doesn't help, then maybe talk to your interviewer and say, you've caught me off guard on this one. I know I've seen something similar. I'm going to take 60 seconds to look at the whiteboard and think about this, or maybe I'll talk you through out loud my approaches. And then if you can't open the dialogue up with your interviewer, then maybe you can go down a certain path and say, I'm going to assume X, Y, and Z, and that's why I favor this approach over a different approach. Even if that's not the right solution, or you're ultimately going to yield maybe an algorithm that cannot be improved if you go down that path for solving the problem, the interviewer is still learning something about you. They're learning that you have the emotional intelligence to understand when you are having a difficult time, and the communication skills to articulate that, explain what the problem is, and seek help basically from your interviewer. So don't beat yourself up for these things. I think everybody gets walked on in the computer science world for their interview processes, especially early on in the career. Just do the best you can, always learn from it, and then the next round have something interesting to talk about.
That's really, really good advice. I'm learning things. I'm taking tips here. I love it. Listen, Hunter, thank you so much for joining us. I think it's been great. I think there's been some incredibly useful hints and tips for a lot of engineers. And I also appreciate you sharing a lot of your insight into, some incoming trends and your journey into tech. I think it's plain to see why you are such a success.
Thank you. I appreciate it.